Okay guys, today we're going to do the Unit 6 review. So follow along, and if you need to pause it or if you need to rewind it, that's fine. And if you have any questions, let me know. So number 1 says, write an inequality representing the solution to negative 3x minus 4 is greater than 8. This is basically just telling us solve for x. So we're going to get the x by itself. We're going to start off by adding 4 to both sides because that will get rid of our minus 4 there. So that cancels to 0. We're going to bring down our negative 3x. Going to bring down our greater than sign. And then 8 plus 4, that's like terms. So that's 12. Now we just have to get rid of the negative 3. And notice it's touching the x, so we're going to divide by negative 3 on both sides. Remember that when you divide by a negative, that is when you have to switch the inequality symbol. So now it's going to say less than. So bring down our x, or our 1x. And 12 divided by negative 3 is negative 4. So x is less than negative 4 would be our solution to this inequality. Number 2 says, is negative 1, 3 a solution to this inequality? Now you could solve for y and graph it and then shade it and then see if this point is in the shaded area. But an easier way to do that is just to call this x and call this y. And we're going to plug that in for the x and the y in the equation and then see if it's a true statement. So I'm going to rewrite my inequality with blank spots where the x and the y were. So I've just rewritten this, and then instead of the x, I'm going to insert the number negative 1. And instead of the y, I'm going to insert the number 3. And then we're just going to do this math and see if it works out correctly. So 3 times negative 1 is negative 3, and 4 times 3 is positive 12. And we want to see if that's less than or equal to 15. And so I know that negative 3 plus 12, you can use your calculator if you need to. That's going to give me 9. And 9 is less than or equal to 15. So yes, this is a solution. Number 3, you have to work 2 jobs in order to pay the bills. House cleaning pays $5 per hour. And your sales job pays $8 per hour. You need to earn a minimum of $254 each week to pay your bills. Write an inequality that shows the various numbers of hours you can work at each job. So I'm going to use H for my housekeeping job, and I'm going to use S for my sales job. So $5 times every hour I do house cleaning plus $8 times every hour I do sales. And I know that what I'm looking for is $254 at a minimum. If that's the minimum I want, that means I would be happy to earn more than that, but I have to at least make this much so that I can pay my bills. So my symbol here would say I could make greater than or equal to $254 and still pay my bills. So there's our inequality. Number 4, Stacy bought X number of headbands at $2 each and Y number of earrings at $5 each. She can spend no more than $40. Write an inequality that represents the amount of headbands and earrings she could have purchased. So I know that it's $2 for every headband, which is X, and it's $5 for every pair of earrings, which is Y, and I know that I can spend no more than $40. So I'm definitely not going to write a greater than sign here because greater than means more than. So I could spend less than or equal to $40 for this one. Number 5, Dylan works as a mechanic at Quick Car. He uses the linear expression 8x plus 3 to calculate, to calculate his hourly earnings in dollars. There we go. Okay. What is the fewest number of cars he can work on in order to earn more than $50 per hour? So more than $50 per hour will be greater than 50, and they already gave us our part of our inequality here. And so that's all I want. Not more than or equal to, just more than. All right, the last one on this page. For a fundraiser, a youth group will be showing a play. The price for student tickets are $2, and the price for adult tickets are $3 each. The group needs to sell at least $80 worth of tickets to make any profit. Write an inequality to describe this scenario. So once again, I'm going to do $2 times the student tickets. I'll use S for that. And $3 for each adult ticket. I'll use an A for the number of adult tickets. And then I know I would be okay with making $80. And if I want to make at least 80, that means I could make more than 80 or equal to 80, but not less than 80. I would be unhappy if we got less than 80, so I need to put a greater than sign there. Okay, number 7, graph the solution to the inequality. This one is a little trickier because it starts off with distribution here. We have to distribute the -2. So -2 times x is -2x. And -2 times -7 is +14. I'm going to bring down my greater than symbol and bring down my -4. And then now you're just going to solve it by taking away 14 from both sides. +14 minus 14 is 0, so I don't need to write that down anymore. And I'm going to bring down my -2x. I'm going to bring down my greater than sign. And -4 minus 14 is -18. Use your calculator for that if you're bad with negatives. Now we need to divide. The -2 is touching the x, so I'm going to divide by -2. -2 divided by -2 is 1, so that cancels to a 1. And so I have 1x. I'm going to move it over here. I have 1x, or just x. I divided by a negative number, this -2, so I have to flip this over. Now it's less than. And negative divided by negative is going to be positive. So x is less than 9 is what I get here. Number 8, graph the inequality. We're going to do the same thing. We're going to solve for y in this case because we want to graph it on our graph. So we're going to subtract x. If that confuses you, you can put a 1 in front of the x. And you can write minus 1x. That's the same thing. We need to do the same thing on both sides. So 1x minus 1x is 0. That cancels out. I'm going to bring down my 4y. And I'm going to rewrite this as -1x minus 16 because I can't combine these. They're not like terms. And I want to put my x first so that when I'm finished, it looks like y equals mx plus b. Now I need to divide by 4. Everything gets divided to keep it even. Switch markers. So we get y is less than or equal to, I'm not going to flip it this time because I didn't divide by a -4, I just divided by regular +4. This -1x over 4 is the same as -1 over 4x. And -16 divided by 4 is -4. So here is my inequality. This looks just like y equals mx plus b. So my beginning, my b, which is my y-intercept, is going to be at -4 here. That's where I'll begin. And then my movement, my slope, is going to be down 1 because it's negative, and then to the right 4. So down 1 to the right 4. And you can always check this in your calculator to make sure you've angled your line the correct way. Then I'm going to look at my symbol. It says less than or equal to. That means I am going to draw a solid line because it does say equal to. And I'm going to shade less than the line. Less than looks like an L. L is lower. So I'm going to shade everything lower than the line. And so here are all my solutions, including the points that are on the line here, because that's a solid line. Number 9, Michael wants to rent a vehicle, but he can spend, this should say spend, but he can spend no more than $200. A local car rental company charges 20 cents per mile plus $40 for a midsize sedan. This can be modeled with this equation or formula. inequality, where M is the number of miles driven. Solve and graph the inequality to represent how many miles he can drive the rental car. So they just want us to solve for M, which is our miles. Don't forget that these are 20 cents with a point in front of the 2. Don't leave that off. So we're going to start off by getting rid of the positive 40. So I'm going to minus 40 on both sides. So I get 0.20 m is less than or equal to 160. And then I'm going to divide by 0.20. And I get m is less than or equal to 800. And then we're going to think about, does that make sense? That's a big number, but that's the number of miles he can drive. So he can drive less than or equal to 800 miles and still only spend $200 or less. So that sounds right, because it's only 20 cents per mile. Okay. Number 10, for which point on the graphs is x less than 2 and y greater than or equal to negative 3? So I'm going to take these and graph these lines here. X is less than 2 would be, here's 2 on the x-axis. Oh, y'all can't see that, sorry. Here's 2 on the x-axis. I'm going to draw a dotted line, and less than 2 would be to the left of this line. So that's that one. And at the same time, they want y to be greater than or equal to negative 3. So for y, here's my y-axis. I'm going to go to negative 3. And this is a solid line. And they want it to be greater than, which means I'm going to shade above the line. So I'm just going to double check my math here, but it looks like we have 2 correct answers here. The P, of course, is going to count because it's in the double shaded area. So for sure, the answer is P. Okay, but also the N is on the line, and this is a solid line because it's an equals to for my orange. So it's on the orange line, which is a solid line, and it's in the blue shaded area. So the N also counts as an answer. So there's 2 points here that are correct for this question. Okay, number 11, a gym calculates the cost to have a membership by using this function. In this function, X is the length of a membership in months. If Omar only wants to spend $180 on a membership, what is the maximum number of months he can join a gym? So we're still going to have the 100 plus 10 times the months. But he wants to spend $180 at the most. So we can only spend less than or equal to $180. And then they want us to figure out the number of months he can join. So we're going to have to solve this. I'm going to start by taking away 100. These will go to 0. So I get 10x is less than or equal to 80. And then I'm going to divide both sides by 10. And so x, which was the months, could be less than or equal to 8 months. So he can join the gym for 8 months or less. Number 12, graph the inequality. This is already set up for us in y equals mx plus b form. So my beginning point, my y-intercept is 3. And this is negative x, which is the same as negative invisible 1x, which means I'm going to go down 1 over 1. Once again, you could type negative x plus 3 into your y equals in your calculator and make sure your line is correct before you start shading the line. This is going to be a dashed or a dotted line because it's not equals to. So I'm going to represent that these points are not correct solutions by showing a dotted line. And then this says greater than. Remember, less than would be lower. So greater than is above. We're going to shade above the line here. And so here are all of the solutions. Number 13, Matt bought a car for $3,000. Each year its value decreases by $400. Write an inequality that Matt can use to determine why the number of years it will take for Matt's car to be worth less than $1,800. So he started off at $3,000. It decreases by 400 every year, which means it's gonna, 3,000, there we go. It's gonna go down by 400 times the number of years. And we wanna set that up to be less than $1,800. Less than $1,800. So that's my inequality. Number 14, write this inequality in slope-intercept form. That just means in y equals mx plus b form, which means they want us to solve for y. So I'm going to start by getting rid of my x term. I'm going to minus 4x on both sides. Bring down your negative 2y. Bring down your less than sign. I'm going to rewrite this because we can't combine it. These are not like terms. So I'm going to write the negative 4x part first, and then I'm going to write the positive 8 so that it looks more like what I want when I'm finished. And then the last step is to divide. And we're going to divide by negative 2 because that's what's touching the x here. I mean the y, so that's what's multiplying. Remember, when you divide by a negative, we're going to flip that over. Negative 4 divided by negative 2 is positive 2x. And 8 divided by negative 2 is negative 4. So there's our inequality in slope-intercept form. Two more. This equation or inequality looks confusing because it's so simple. So if this confuses you, type it in your calculator and you'll see it's the same as saying 1x plus 0. So they're going to start at 0 and then they're going to go up 1 over 1. And this is a greater than or equal to, so I'm going to draw a solid line. And it's greater than, which means I'm going to shade above. And I'm going to do that pretty lightly because I still have another line to graph. Okay, my other line, the beginning point is positive 3. That's my y-intercept right there. And then it's negative 1/2, which means I'm going to have to go down 1 over 2. So there's this line. This one says less than or equal to, so it's still a solid line. These points on the line still count because that equals to. But it says less than, so I'm going to shade below or lower than the black line. And so my answers or my solutions are in this double shaded area right here, including on these lines, because these are solid lines. Okay, last one. We're going to need to set these up and solve. So I'm going to let you guys do that on your own, and then you can check your answer in class. Okay, so if you solve them both out, the top equation, I got y is less than negative 2/3 x plus 4. And so we're going to graph that one first. I'm going to start at positive 4. And then I'm going to go down 2 over 3. And I'm going to draw a dotted line and shade lower than the line. Always do one line completely, drawing and shading, before you do the next one, so you don't get lost in what you're doing. For the other one, when I solved it, I got y is less than 1x minus 4. We had to flip our inequality here. So I'm going to start at negative 4, and I'm going to go up 1 over 1. And this is a dotted line as well. And it says less than, so I'm going to shade lower. And so our double shaded area, our solutions, are not touching the orange line or the blue line, but in just the double shaded area here on my graph. And that's it. If you have any questions over any of these, please rewind and rewatch, or you can ask me in class.